and we will go over to John. John, are you ready?
So I will...
Yes, I am. Hi, so I'm John Readey. I've been with the HDF Group for 8 years, I think now, and I focus mainly on what I call cloud enablement of HDF5. And today I'd like to talk about recent work we did for serverless support using two different techniques, AWS Lambda and Direct Access. So next slide. So I'll talk about a little recap of HSDS. I gave a couple of talks last year, but for those who weren't able to attend last year, I'll just do an overview of that. And also talk about the HSDS storage model, then move on to AWS Lambda, and finally talk about how direct access mode works. So HSDS, the idea is a REST-based service for HDF data. And our design criteria were to be performant, scalable, feature complete, and support a variety of different storage systems, notably cloud storage systems like AWS S3 and Azure Blob Storage. Originally, it was part of a NASA Access grant, and since that grant ended 4 years ago, we've extended and continued development on HSDS. The architecture of HSDS is basically a container-based system where you have multiple containers. You have these service node containers, which are blue guys, that handle user requests, and you have data node containers, the green guys, that read and write to a storage system. And you see there's this complicated cross-stitch pattern between the blue containers and the green containers. This is indicating how we enable parallelism. So for example, with non-parallel HDF5 library, if you read multiple chunks, you have to read one chunk at a time. With HSDS, the service node can distribute individual requests to the data nodes so that you have each data node reading multiple chunks of data at the same time. And this enables a large amount of parallelism, especially since you can deploy this not just on a single server, but on a cluster like Kubernetes. And now your blue and green nodes can be distributed across multiple machines with multiple network pipes and so on. Our set of platforms and storage systems has expanded over time. So we have Docker, Kubernetes, EKS, AKS, DCOS, and different storage systems like POSIX and S3, Azure Blob Storage, OpenIO, and stuff. So let's step back and say, why a service at all? Well, Danny was talking about how you can't download petabytes of data. With a service, you can remotely make inquiries to the data and pull back just what you need. This is called the inertia big data problem. Also, with a service, you have some new solutions for multiple reader, multiple writer clients. The service can be a coordination point, if you will. So if you have, say, 100 reader-writer clients, it's a service that's coordinating those updates to make sure that two clients don't overwrite each other. Provides a language-neutral interface, HDF. So in much of the software universe, the REST API has become the standard API, if you will. And by having a REST API, one, we enable web-based applications, and two, other languages can all plug in to that REST API. And we developed two third language clients, H5PyD for Python, and the RESTful, which is a HDF plugin for C and C++. So these clients provide API compatibility to HDF, but under the covers, those calls are being converted to REST requests that are going to server and client. And finally, for creating container-based applications, it's nice to have your HDF reading and writing be a fellow container, if you will, and that makes it much easier to architect those complex applications. Okay, so next, the storage model for HSDS. So we all know, like, HDF5 is a file, and within that file, you have multiple objects. By contrast, in the HSDS storage model, we store each object as a separate file or object. Okay, So for metadata for a data store group, that stored as JSON. And for chunk data, it's stored as a binary object. So this, we might think, okay, if I have a large data set, don't I have many, many files? Yes, you do. So we've had, air quotes, files that have millions of different objects within them. Since the API and these tools abstract the need from actually dealing with any of these underlying files or objects, it's really transparent to use it. The advantage of this, particularly for cloud, is that in object storage systems, you can't update a part of a storage object. You have to rewrite the whole object. So you want to have the size of these objects be constrained to a few megabytes so that you can efficiently do updates. So kind of recap, so we limit the maximum size of an object. We enable easier parallelism. There's no need to block content. There's no need to manage free space or key value mappings. So one challenge to a lot is that have say default, and the file gets left in a you can't access data. In the sharded model, there's no map of different objects. It's all implicit in how the objects are stored. Here's an example of what it looks like. So for a given root group ID, you have the root group called object1, dataset.json, and dataset.json, you see there's a 0_0 and 0_1. These are referring to two chunks of an apparently two-dimensional dataset. And in object3 ID, we have the dataset JSON metadata and a 0_0_02 and a 0_0_03. So for a, we don't, just like with the HDF5 library, don't allocate all the chunks at dataset creation time. They're allocated as data is written. Okay, so let's move on and talk about the serverless HSDS. We started out creating a service, and we've, feedback that in many situations, having a service can be a challenge. And now we're exploring ways to have the functionality of HSDS, but without the service, or a service as a supplement to functionality. So and these approaches are AWS Lambda support, which we'll talk about next, and direct access model. So, having a service, you can run a large cluster and so on, but that's not always maybe setting up a service is just too much trouble. You don't want the hassle of that. Maybe you're running thousands of clients and you magically scale up the capacity to those clients and then scale down again when those clients are done is too much work. Or maybe you want to have a server that's available 24/7, but you don't want to pay Amazon or Microsoft money to keep that server up just for running what may be a low usage server. So for these situations, AWS Lambda is very interesting. So AWS Lambda is a service Amazon introduced it a few years ago, and they've made several recent enhancements to it just this year. And the idea is that it's a service where you tell Amazon, hey, Amazon, please run this function for me. They run that and return you the result. The price using 1 gig memory is, let me write this, 0.000000167 per millisecond. Okay, which sounds pretty affordable. It can get expensive though, given how many functions you could run. But beyond just cost savings, what's really exciting about it is this idea of infinite elasticity. And what I mean that, if I had a cluster and I scale up or scale down the cluster, that takes some minutes to do this operation. Whereas with Lambda, you can run any workload to any level immediately, right? So if you're doing nothing and suddenly 1,000 requests come in, you can run 1,000 requests simultaneously. Beyond that, it's nice that you don't need to deal with managing machines, right? There's no OS patches or backup, monitoring, blah, blah, blah. It's all just there, always just works. So that sounds great. Some challenges though. Given our large set of software we have now with HSDS, we can't just throw it on Lambda and have it run. In Lambda, you need to initialize the system as quickly as possible because it has to be initialized from a cold start every time a request comes in. There's no caching because there's no context continuity between different invocations of a Lambda function. You're limited up to 6 CPUs per function, and the runtime environment is restricted. This I found out by doing some work and seeing these restrictions. There's no Docker within the Lambda function. TCP is not allowed, and shared memory is not allowed. I imagine these restrictions are because since your Lambda function is rubbing shoulders with other users' Lambda functions on what's probably the same machine, they don't want to allow any kind of confidentiality leakage between Lambda functions. So the approach we took here is to enable these nodes, instead of running on containers, to run as sub-processes of Lambda function code. So on startup, we create a number of sub-processes equal to the number of vCPUs for the DN nodes. And instead of using TCP, we use Unix domain sockets. And so when a request comes in, the payload's unpacked. We spin up these SN-DN nodes. We send a request to this SN node. That distributes the words over the DN nodes. The nodes read and write to S3. They return the response back to SN node. The SN node returns the Lambda result, and then we tear it all down again. So it's like, imagine, spinning up your server, taking one request and shutting it down again, which seems really inefficient. But since we can do this all within a fraction of a second, it's not actually that prohibitive. So results of testing are this. So compared with HSDS running on a dedicated server, the response time will be anywhere between 2 to 100 times slower. So this is because you need 2 to 4 seconds for a cold function to start up. So Lambda has cold versus warm versus hot functions. So a function that has been called recently will be cold. And invoking that function becomes warm or hot, and then that
John, we just lost you for a few seconds there. Maybe you can repeat that.
Oh, okay. On the performance constraints page?
Yeah.
Yeah, I'd say that as it gets warmer and this latency decreases. Much higher latency for Lambda than for HSDS running on a dedicated server. In simple testing, we have set, and I want to access one column, taking all the values, say, in one column in a fixed X and Y location. This involved accessing 400 chunks and returning 39 kilobytes of data out of 1 gigabyte of data access. So at the baseline, with the server HSDS, that operation takes about 5 seconds and processes by 30 seconds. Lambda, on a cold on for Lambda function. They'll call.
Yeah, I think we've lost you completely. It's breaking up. It's silent now. We can't even hear you.
I hear you.
You can hear us? Okay.
Yep.
I don't know what. So the time is officially up. We're on slide 17. How or do we need to go further down? 18.
Hello, do you hear me?
No, but it keeps on breaking up. Yeah.
Okay. Yeah, I guess we're almost out of time. So let me say that the advantage of Lambda, though, is that you don't have to provision a server and you have this infinite scalability. And then on slide 18, the direct access architecture, let me just briefly summarize. We use the same kind of concepts as Lambda, but we enable the HSDS code to run as a sub-process of the client. So again, there's no server, but all the code executes on the client. And then on slide 19, I have a diagram of the architecture. I talk about the Vol plugin. So this would enable basically HDF5 using a sharded file format and these enhanced capabilities that we have with HSDS. And this should all be, Lambda is available now as preview, and everything should be released this summer. And that's it.
Okay, well, thank you. I'm sure there was a question about HSDS in the previous talk already. I don't know if you got that.
Yeah. Danny had a question about running on Gluster, I think, right? Yeah, it should be fine. I would say try it out. And also, I think this direct access mode might be of interest as well. And also, I know Danny was interested in virtual data sets. Virtual data sets actually is one of the features we don't have directly in HSDS, but we have a similar concept where you can link multiple HDF files to create one virtual HSDS file. And I think that'd be interesting to apply here too.
Okay, there was one comment from Jerome saying that we should give the cost of AWS in seconds and not milliseconds.
That's actually well, that's true. But you know, it's interesting. When Lambda first came out, they charged by second. So if your if your function took 1.01 seconds, you got charged for 2 seconds.
Yeah.
So it's actually a pretty nice feature. They charge by the millisecond.
But just to get an idea, the speed is slower, but the saving, the financial, the dollar saving is is worth it, yeah.
Right. It's typically, if you had a server that's used, 100% capacity all the time, it would be cheaper to run a server. But if your capacity is anything less than, say, 60%, you'll save money with Lambda.
Okay. Okay. Well, I think the time is up, but I'm sure HSDS will come up again during the discussion. Will you still be there? Will you be online?
Yes, I will. And of course, anyone feel free to reach out to me directly or in the forum if they have questions. Okay, cool. Okay, thank you. Thanks a lot, John. This is Thanks. Sorry about the phone connection issue.
I don't. It happens. I don't know if it's where you are or if it's Zoom, but it happens.